Okay.
Fiddle on our devices.
Okay.
Welcome to the Nerdy News.
Today we have 3 interesting theories proposed by some extraordinary scientists, all related to the field of astronomy.
So, without further ado, let's get started with this Galactic Heroes broadcast. First up is the theory of many worlds. This theory was invented by a quantum physicist named Hugh Everett to answer questions about quantum mechanics and the wave function. The wave function is a quantum law that deals with objects in multiple states. To explain this further, I'm going to use the thought experiment of Schrödinger's cat as a guide to help. In this hypothetical experiment, a cat is placed in a bunker with a barrel of unstable gunpowder that has a 50% chance of exploding. The scientist does not know if it exploded until he opens the bunker and he checks. The wave theory says that, before the scientist checks the bunker, the gunpowder and the cat are in a quantum superposition, which means they're both dead and alive. The gunpowder has both exploded and not exploded, and that as soon as the scientist opens the door and checks, he forces the collapse of this quantum superposition into one observable reality. So for many years, scientists did not know how this collapse happened or into what position the collapse was determined. Under the theory of many worlds, however, all of the possible states are accommodated for. At every point in which a quantum superposition can occur, the universe actually splits in two, and each possibility is carried out in a separate universe, as the theory goes. In the case of Schrödinger's cat, in one universe, the cat would be alive and the gunpowder would not have exploded, but in a newly created parallel universe, the same scientist would find that the same barrel of gunpowder had exploded and the same cat would be dead. To sum it up, at any time in any person's life where they faced a decision with more than one possible outcome, the entire universe would have split and every action is accounted for. For example, let's say you had to choose between eating cake and ice cream. The universe would split, and in one universe you'd have cake, and in another you'd have ice cream. Now let's say that the ice cream you ate was way past its date and all moldy and gross, and right as you finished you realized that you might have to go to the pharmacy to get medicine in case you got sick. The universe would split again, and both actions would be taken. So in 3 parallel universes, you would be fine in 2 of them, which was the cake and the one where you actually went to the pharmacy, but in the 3rd, where you ate the ice cream and then stayed home, you'd be sick. This theory has actually been proved to be plausible, but it has not been physically proven either right or wrong. Garrett?
Next is the wormhole theory. The wormhole theory is a theory that states that gates to a different part of space-time, or wormholes, exist. These gates can allow us to instantly travel to other parts of the universe. However, it also has many problems. It was originally proposed by Doctors Einstein and Rosen in 1935 after studying Einstein's theory of relativity, and that is why wormholes are called Einstein-Rosen bridges. Wormholes can be created from 2 black holes, but that itself is just a thought because we don't know much about the nature of black holes. And wormholes are expected to exist on microscopic levels, being as wide as 10 to the negative 33 power wide in centimeters, and that's very small. And also, because of the laws everything in the universe must follow, Einstein-Rosen bridges are expected to last for only fractions of a second because they'll collapse on themselves. And they collapse on themselves because a special matter isn't present. So, because wormholes have not been found, because they're too small and they exist for tiny, tiny parts of time, it doesn't look like we'll be able to see any soon. But scientists do think they can overcome those problems in the future when more advanced technology and discoveries have happened. They propose that wormhole travel can still be possible, and they have numerous ways to do this. To find wormholes, scientists would look for light that has been distorted, just similar to black holes. Because of the way they work, they take space and time, and they bend it to come together, and light has to follow that path, so it would be bended and distorted, or bent and distorted. Also, they collapse on themselves because there is not enough what scientists call exotic matter. And exotic matter isn't like regular matter or dark matter, where it's a sort of matter that has has a very negative density, which is hard to imagine, and an extremely high negative pressure. So it's unlike anything we've ever seen. But it has been found in special vacuums in the quantum field theory. And this kind of matter could support the wormhole, and if it had enough of this matter, it could be sustained for long periods of time. And scientists think that we could potentially travel through one and overcome the size dilemma by just the fact that the universe has been around for 14.4 billion years. Because they started off so small and the universe is expanding from the Big Bang Theory, that they've gotten bigger over time because they are part of the space-time. And so hopefully after 13 billion years, the wormhole has grown to a size that we can travel through. So in conclusion, we may be able to instantly travel to a different part of space and time by going through a wormhole, overcoming hundreds of thousands of light years, but it doesn't look like we'll be able to do that anytime soon.
So third and last is the Big Crunch theory. The Big Crunch theory was first proposed in 1927 by the German priest Georges Latreille. In essence, the theory states that an uncountable number of years later, the universe will stop expanding as it is currently and shrink back into a singularity point of infinite density. This point would hold all the energy and matter that is in our current universe. To completely understand the Big Crunch theory, it's important to have some background information about the Big Bang theory, because the Big Crunch theory is a result of the more famous brother, the Big Bang theory. So the Big Bang theory started when a point of singularity exploded and particles of energy were released out, and expansion of the universe began. As the temperature decreased, more stable particles such as protons and neutrons and electrons were formed. Gravity brought matter and these particles together to form stars. These stars became hot enough due to friction, and the process of nuclear fusion began, and neutrons and more heavy, dense elements were formed. Gravity also brought together stars and other matter to form galaxies, superclusters, and solar systems, including our own and our home planet we call Earth. The Big Crunch theory has two counterparts. One prediction to our universe is that it will be open-ended. The universe will expand infinitely. Stars will eventually run out of fuel, and galaxies will become coffins of dust and darkness. The other prediction we have is known as a flat-ended universe. The universe will continue to expand, and then, over time, slow down and stop, but not contract. The only difference between a flat universe and the closed universe, another more commonly used name for the Big Crunch theory, is that the closed universe will begin to contract, eventually forming the point of singularity that our universe started with. The exciting thing about having the future of the universe be a closed-end universe is that the point of singularity that the universe would be theorized to end with could give birth to the same process and have another Big Bang. And the universe would go through the constant cycle. The universe would expand and then contract back and repeat the process. Interestingly, cosmologists think that our current universe could have been a result of a previous collapse. But is there any evidence that cosmologists have to support the Big Crunch? Well, yes, gravity could eventually win and bring everything back together, but that is unlikely because it has been discovered that the universe is currently increasing its rate of expansion. So the theory of a Big Crunch is most likely not the destined end of our universe. But it is one more interesting and fun way to think of the end of the universe.
Well, that was all. Thank you for watching our podcast. Listen to it the entire time. Just balls.
Could have done so much. Okay. Welcome to the Nerdy News.
let's
Okay.
just start again, because
Welcome to the nerdy news. You can't do it.
yo. Yo.
Got it. Better.
Okay.
The Big Crunch theory was first proposed in 1927 by a German priest. I know, it's not gonna work.
Why'd you put that on there?
You messed up.
Okay, let's start from yours because we have editing tricks.
It can't work until it's gone.
Hello. I don't even know how to use a map.
Well, that's some usable stuff right there.
Bloopers. Don't I'll get rid of it.
Close the window.
Hold on.
There.
No,
Now we have a space-time continuum.
it's not gonna work. You're just
It's the
gonna
fabric. It's the
bullshit.
fabric of space and time.
You're gonna hold
Chris,
up a picture
start.
of a cat falling from a couch here.
Okay.
Start.
Before we start, how would you guys say that name?
What?
George's
Lemaitre.
George is a matron.
George's the nature. Okay. Okay, so our third and last theory today is the Big Crunch theory. The Big Crunch theory was first proposed in the 19th. No. No. Bye. Bye.
It's Halloween. How was it?
It's gone.
You.
Garrett, you bad
I'm
person.
supposed to be
Okay.
origins
It's
too.
gone.
You know how hard it's gonna be the end of this video.
Sorry.
Bad.
You found a statue.
I have to do the editing.
I can help you. I'll be here longer. It's fine.
Mm. Why?
I was gonna eat that.
No, we should like have half of these props gone during Christmas. Just have a prop kid.
Why?
Oh, there are my Tic Tacs. Wait, get the fuzzy.